Having a language that is written in numbers and symbols has been an idea that has lasted for so long. Many new concepts have been added, which have made the use of numbers as a language richer and more user-friendly. In this video, we are going to introduce ourselves to this kind of language. We've called it indices. Now, where exactly do indices come from? Indices actually arise from the multiplication of similar factors of a given number a number of times. For example, right in front of your screen, we have 2 times 2 times 2. If you look at that, 2 has been multiplied 3 times. That's why we are calling it 2 to the power 3. Here we have 2 times 2, then we have 3 times 3 times 3. 2 times 2 has been multiplied 2 times, that's why it is 2 to the power 3. Then 3 has been multiplied 3 times, that's why we are calling it 3 to the power 3. The power represents how many times the number has been multiplied. When you look at 2 to the power 3 or 3 to the power 2, this is the general term, x to the power n. And we are saying that this bottom number is the base, and the power is what we are calling the index, and the index or the power, that's why we call them index numbers. It therefore follows that for 2 to the power 3, 2 is the base, 3 is the power. Right, same with this, 3 to the power 3, 3 is the base, and that 3 up there is the power or the index. So we are going to proceed to look at the laws that govern indices. These are the very laws we use when we are calculating and manipulating numbers that involve indices. Right here we have, in general terms, if we are having a to the power p times a to the power q, if the bases are the same, then you simply call it one base and you add the powers. So it's going to be p plus q. For example, you're having 2 to the power 4 times 2 to the power 3. The bases are the same, it is 2. So you simply maintain the base and you add the powers, 4 plus 3, giving us 2 to the power 7. This is when you're multiplying indices. If it is division of indices, it is we are dividing indices of the same base, we maintain that base, and we subtract the powers. In this case, it will be m minus n. Then we have a to the power p, all this is in brackets q. This is the same as saying, it's the same as multiplying these powers, up p times q. Just like in our example here, this is 8 squared, but this whole index is again to another power 4. It's the same as multiplying these 2 by that 4, and 2 times 4 is 8, so it's 8 to the power 8. That's the answer to that. And then we have a to the power negative p. Now that negative it serves to represent the inverse, or the inverse of this, or the reciprocal of a. So a to the power negative p, to be able to remove that p means that you put this a in the denominator, so it's going to be 1 over a to the power p. For example, 2 to the power negative 5 gives us 1 over 2 to the power 5, which is 1 over 32. Or you can, this is the same as saying 1 over 2, and this whole thing is to the power 5. It's the same. This is the reverse of what we did before. 1 to the power negative p, to remove that negative means you're going to find the reciprocal of a, and the reciprocal of a means a gets to the numerator and this one gets to the denominator, which is a to the power p. So in our example here, 1 to the over 8 to the power negative 1 is the same as 8 to the power 1. It's the reciprocal of that number that gives you the number to the power that digit without the negative sign. Then we have a over b to the power negative p. Again, if you want to remove that negative sign, you simply find the reciprocal of this. And so of course the reciprocal of a over b is b over a to the power p without the negative. And in our example, it is well illustrated that 2 over 3 to the power negative 2, to remove that negative sign, you get the reciprocal of this. So it's going to be 3 over 2 to the power 2 without the negative. Then there's another identity here that a to the power 0 is 1. Whether it's 1,000 to the power 0, or 1,000,000 to the power 0, or 20 to the power 0, any number to the power 0 is 1. 100 to the power 0 is 1. Now, when we are dealing with numbers, when we are dealing with index numbers, it is important that we have these laws that govern indices on our fingertips. Because when we are interpreting numbers such as these, it is these very laws that we are going to use to interpret them. It's important that you memorize them so that they are at your fingertips. We are being required here to simplify 2 to the power 3 times 2 to the power 4 times 2 to the power negative a half. And if you look at this number, we are having multiplication of these index numbers, but the base is the same. And since the base is the same, so it means we are going to maintain it. So it means it's going to be 2 to the power. In multiplication, when the base is the same, we add the power. So it's going to be to the power 3 plus 4 plus negative a half. And our answer is going to be 2 to the power 13 over 2. Right here, still the same 5 times 5 times 5. This index, it's multiplication of indices, so we maintain the base since it's the same. So it's going to become 5 to the power, you add the powers. So it's going to be 4 plus 3 plus negative 1. And definitely this is going to become 5 to the power 4 plus 3, 7. 7, this becomes minus. 7 minus 1 is 6, so it's 5 to the power 6. We have another here, it is 3 to the power 5 times 3 to the power 6 divided by 9. Now, when you're dealing with index numbers and we identify that it is being mixed up with a number that is not an index number. For example, here 9 is not represented in form of an index number. You try and first convert it into an index number so that it looks like the rest of the numbers. Then you can go ahead and simplify it. For example, 9 can be represented as 3 squared. So it means that this becomes 3 to the power 5 times 3 to the power 6. Divide that by 3 to the power 3. Because 3 to the power 2. This 3 times 3 is 9. So this here it's multiplication, then here it's division. So it means what we do here, since the base is the same, we are going to maintain the base. And with this multiplication, we first add. It's going to become 5 plus 6. So here it is 3 by 3. So we add the powers because it's multiplication of indices, which is 5 plus 6. Divide that by 3 to the power 2. So this becomes 3 to the power 11 divided by 3 to the power 2. Now division, with division here, when the bases are the same and it's division of these indices, we subtract the powers. So definitely here it's going to be equal to 3 to the power 11 minus 2. And this is going to become 3 to the power 9. This brings us to the end of this video. Thanks for tuning in. For more of these, simply subscribe to this channel. For Kisembo Academy, this is Arnold Rangakurami.